So today we're taking a look at all of these different types of functions. Now this function type is technically called a reciprocal function. That's the sort where we're taking something and dividing it by x. And we just are starting with taking the equation and applying some transformations to it so we can see how they would actually show up in this sort of a format. All right, so the first thing we do when we're writing these types of equations is start by just thinking of the parent function. So I'm just starting by thinking about the y equals 1 over x. And then I'm just plugging the pieces into it that are my transformations. So in order to shift right 3, remember shifting right 3 means I have to subtract 3 from the x. Now notice the x is in the bottom of the fraction. So that means that the minus 3 is also in the bottom of the fraction. And remember, it's minus because right is minus, left is the plus. All right, then next up, we're going to shift it up 5. Whenever we've shifted up 5 with previous functions, that's meant that we've just had a plus 5 hanging on the end. This is going to be no different. So we end up getting y equals 1 over x minus 3 plus 5, and that's the final answer. And in case you're curious, can it be simplified? No. There's no way that we could simplify that any further. All right, so for writing this equation, again, I always start with the basic structure of the parent function. So I start with the y equals 1 over x. And then I just start going down my list of transformations. So the first thing here is a reflection across the x-axis. Remember, if I'm going to reflect it across the x-axis, that is, I'm going to flip it upside down, that means putting a negative out in front of it. So that makes it a negative 1 over x. Now, to vertically stretch by a factor of 2, that means multiplying my equation by 2. Now, at first, it might seem like this would then be the way to do that, but I actually am going to tweak that a little bit because this looks slightly awkward. It can be cleaned up. So rather than writing the minus 2 times 1 over x, I can actually write it as a negative 2 over x. That's the same thing, because when I multiply a fraction by a whole number, that whole number just multiplies into the top. And yes, it is good form to leave the negative just hanging out front of the fraction. The negative does not go into the top or the bottom specifically at this point. I'm just writing it as a negative fraction. But just for perspective and a reminder, if you did put the negative into the fraction, it would not go into both the top and the bottom. It would go into either the top or the bottom, not both. All right, so then that's our final answer. Having done those first two, I feel like you should be able to now do this problem. This is just putting the pieces together that you saw in the previous ones. So go ahead and try writing this equation, and yes, of course, into your notes, write down what transformations you're doing to it to connect to your equation. All right, so again, in order to write the equation, we start with our basic parent function. We're just kind of building onto it here. So the first thing is a reflection across the x-axis. That means make it a negative. So I write that negative out in front. Now I need to vertically stretch it by a factor of 4. Remember when I stretched it by 2, the 2 went on the top? The same thing's going to happen with our 4. I end up with 4 over the x then. But I still need to shift it down 7. So shifting it down 7, remember up and down is going to be hanging on the end. And so that's going to be a minus 7 hanging on the end of our equation. Last thing, to shift it left 8. Anytime we're moving left and right, that means it has to be down with the x wherever x is. And so left 8 would be plus 8. So that means I'm going to write it as 4 over x plus 8. Then this would be your equation. Although I do want to bring something up on this. You'll often see these equations written this way, or you'll see them written this way. Notice it's the same thing. All we did was write this minus 7 or negative 7 first when we wrote it this way. It means the same thing. So even though we're writing this negative 7 first, it's still shifting it down 7. Remembering and seeing that these two are in fact the same equation with the same transformations in them will help you quite a bit, because otherwise all of a sudden when they reorder it, You might think something weird's going on when it isn't. Right now I'd like to summarize what we just saw about our reciprocal functions here. And so go ahead and add this into your notes. You'll notice a couple empty dots there. We're going to fill those in after we do a little bit more practice here. So we're now going to take a look at what the graph of y equals 1 over x would look like. And whenever I'm starting a new graph, I tend to make a table of x and y values. And when I do that, normally the first number I like to pick is 0. Although that creates a little bit of an awkward situation in this particular problem, because if I plug in 0 for x, that's going to give me 1 over 0. Well, we can't divide by 0, remember. Anything divided by 0 is actually undefined. And so that gives us something a little bit weird there. So let's put that on the back burner. We'll come back to the 0 here in a moment. So then I might next go to 1. So that means I'm now going to do 1 over 1. And 1 over 1, of course, equals just 1. So I can then plot the point 1, 1. And then I go to x being 2. Well, notice if I plug 2 in for x, that gives me 1 over 2. It's just a half then. Nothing else that we have to do with that. And so then that gives me the point that I can plot at 2, 1/2. And I can really just keep doing the same thing. If I do 1 over 3, I get a third. If I do 1 over 4, I get a fourth, and so on. So notice what's happening in these points over here. They're all getting closer and closer to the x-axis because it's going to be 1 over whatever that x-coordinate is. So if I go out to x being 1,000,000, I'd go up 1 over 1,000,000. So it's always getting really close. Is it ever actually going to hit the x-axis over there? No. All right. So we can see what's happening going this direction. But there's this slightly awkward space here between 0, where it was undefined, and 1. And I'd like to see what's going on in there. So from here, let's go ahead and grab an x value of 1/2. That means that I'm doing 1 over 1/2. What's 1 divided by 1/2? Well, let's remember how we divide with fractions, because 1 divided by 1/2 would be the same as 1 times 2 over 1, or in other words, 1 times 2. And we know that 1 times 2 is, yes, 2. And so you notice we actually get the point of 1/2, 2. And as you might expect, the rest will go very similarly. So like, if x is 1/3, y will be 3, and so on. And so then we can see what this graph looks like. There's a certain symmetry going on up there in that first quadrant. Notice as we're going up over here, am I ever actually going to hit the y-axis? Nope. It never actually hits or crosses the y-axis there. Right, but that only looked at the positives. What happens with the negatives? Well, if I do 1 over -1 like this, so 1 over -1, if that thing will write correctly. What's 1 divided by -1? It'd be -1. What would 1 over a -2 be? Well, that's just a -1/2. Same kind of thing with the -5. That gives us -1/5. The -1/2. Well, remember, 1 over 1/2 gave us 2. So 1 over a -1/2 will give us a -2. It's basically all the same things except that they're negative. And so if I go through and actually start plotting those, my positive becomes a negative, both the same ratios. And so you can see then that I get these points, and yes, you can see the curve that gets drawn in through those. Now, having done that, we can now go back and take a look. What is this telling us, the 0 that's undefined? Well, remember these points up here, they're getting really close to the axis, but they never actually hit 0. The points down here, they're getting really close to the axis, but they never really hit 0. What do we call one of those lines that the points are approaching but never actually crossing? Yep, that's the asymptote. And so this graph actually has a vertical asymptote here at 0, and it has a horizontal asymptote at 0. This graph has two asymptotes perpendicular to each other. They're starting at 0, but as you might expect, later on we'll be transforming these so that we can move them around and all that kind of stuff. I do always want to draw in the asymptotes with dotted lines. That's going to be especially important as we start shifting these graphs around, so remember to do that. And so if I have a vertical asymptote at x equals 0, and remember vertical is x equals, and a horizontal asymptote at y equals 0, that tells me something about my parent function. This is how I'd like you to fill in those two empty dots from our previous notes. So note here are asymptotes. Those are the last two pieces of information about our reciprocal function that you're going to need from today's lesson.